Good morning, guys. My name is Ad Al Mahjari, and I will be teaching you physics for a while as part of my training for QTC certificate or QTC qualification. Before we start, just to tell you a little bit about myself, I have a bachelor degree in physics and also a master's degree in renewable energy and sustainable development from Jordan University of Science and Technology. In this chapter, we will be focusing on momentum and collisions. The chapter is divided into three sections. The first lesson will be about linear momentum, and then we will talk about change in momentum and the impulse. And then the third section will be about the conservation of momentum. Okay, so today we will just focus on linear momentum. Let me see the pointer where it is. Okay, so let's start. Linear momentum. The learning outcomes of this lesson, or what I expect you to be able to do by the end of the lesson, are the following. I would expect you to be able to describe momentum using some real life examples. Try to associate momentum with the phenomena or the physical phenomenon around you every day. And also to be able to define linear momentum using simple mathematical equations, simple equation, to apply this equation also to calculate or solve problems in momentum, and to understand the dependence of momentum on mass and velocity. In other words, to be able to describe the relationship between momentum, mass, and velocity. Finally, I would also expect you to be able to compare linear momentum for different objects at different velocities. In other words, how if you change the velocity or the mass of the object that is moving, how the momentum will change and so on. So please read those objectives or linear outcomes, learning outcomes. Read them before you go ahead, because they will help you or guide you through the learning process, and uh, they will help you understand the lesson in a better way. Okay, what is momentum? In order to answer this question, let's analyze this situation or this scenario here. When a moving car suddenly stops or hits a large object, passengers feel pushed forward. And I think most of us have experienced such phenomena. If you are driving in a car with father, or if you're um, driving yourself, and sometimes if you have to hit the brake, you will feel your body moving forward. Or la samah Allah, if someone made an accident, they will also feel their bodies pushed forward. So we will try here to understand this phenomena and to explain it in terms of physics. And we also have noticed that if the car was moving fast, the damage would be greater. That means there is a relationship, proportional relationship between the speed or the velocity of the moving object and the damage that it will experience if it hits something. Now, let's try to answer the question why. What makes this phenomena happen? Okay, if we look here, we have a car. So the car has mass and it's moving. So it has a mass that is in motion. So we could describe those two things, or those two quantities together, mass and motion. We could describe them as the momentum. So I think it's very simple here to define momentum as mass in motion. So any object that is moving, since it has mass and it has a velocity, so it has momentum. If the object is not moving, it doesn't have momentum. Or if the object is moving but it doesn't have mass, we also say it doesn't have momentum. So let's here agree or conclude that in general, the simple description of momentum is that it is a mass in motion. And to to help you understand this better, you could think of many examples around you every day, when you walk, when you go, when you do exercise, or do anything, when you move, for instance, for any reason, your body has a mass, and since you're moving, you have momentum. Sometimes if you're watching a football game, you can hear, or you may hear the commentator saying, this team is going to win. They have a lot of momentum. What they really means is that those people are on the move. They have their bodies have masses, but they are moving fast, they are running and so on, so they have momentum, they are energetic. Okay. I think that we have a lot of examples around us daily from the daily life that we can think of as an examples of momentum. Okay, so let's move on to the focus of today's lesson, which is linear momentum. Not any momentum, but linear momentum. uh, we have, for instance, different type of momentum, which we call it angular momentum, but we won't cover it here. We will not talk about it in this lesson. You might learn about angular momentum later on in advanced course in physics, but let's focus on linear momentum, and we'll try to understand what we mean by linear. So linear momentum is defined as mass times velocity. That's very simple definition. And you can see here from the equation that describes linear momentum, it's only mass times velocity. Very simple equation, or very simple mathematical representation. Okay, now why we call it linear momentum? The reason behind that is if the object is moving along a straight line, we say that the object has linear momentum. So for instance, the car moving along this highway, it has linear momentum. Okay, like this one for instance, or the billiard ball, when it's moving across the table, it has linear momentum. But for instance, if something is circulating like the moon, it doesn't have linear momentum here, it has a angular momentum. Of course, later on we can learn how to bring the component of linear momentum. But in general, anything that is moving in a circular path, it doesn't have linear momentum, it has a angular momentum. Sorry. So here we can say that linear momentum is the momentum of an object when it's moving along a straight line. Okay, or you can define it in a different way using this definition. So you can say linear momentum is mass times velocity. Very simple. Now we usually represent the momentum or the linear momentum with the simple p, and the mass with the simple m, and the velocity with the simple v, uh, just to make it simple, or to make it short. If you are dealing with problems, you would like to use symbols to make the equations very small and very neat. Okay, so let's conclude here. Linear momentum is mass times velocity. This is the main equation of linear momentum. We call it the governing equation of linear momentum, the equation that governs the relationship between mass and velocity. You can see here momentum changes if the mass changes or if the velocity changes. So it depends on the mass and on the velocity. Okay, so remember this equation. It's the main equation of this lesson today. We call it the governing equation. So whenever you have any problem to solve about linear momentum, you will need this equation. Okay, so let's take an example to make sure that we understand it very well. Here is an example. What is the momentum of a 1000 kilogram car traveling at 25 meters per second north? Imagine this car is traveling at 25 meters per second from Amman toward Erbil. Since I said north, that means it's coming from Amman toward Erbil. Okay, and the car has a mass of 1500 kilogram. So what would be its momentum? Okay, before you see the answer, I would like you to pause the video for a while and try to solve it yourself, and then compare with the answer. The solution. Usually when we solve problems in physics, not just for this lesson but in general in any lesson in physics, start by drawing a diagram for the problem. Here we already have a diagram, and then the second thing you would do is to extract the givens from the problem, and always try to watch out or to check the units if they are consistent. So here the mass is 1500 kilogram, the velocity is 25 meters per second toward the north. This is the direction of the velocity. And then the third step is to write down the governing equation of the topic itself. And this is here the governing equation. Since we checked here the units are consistent, all we do just to plug in the numbers or substitute the numbers here. Instead of m, we write the number of or the value of the mass, and here the value of the velocity, and we multiply them together. It will give me 37,500 kilogram meter per second north. This is the momentum for this car that has this mass and that is moving at this velocity. Okay, now about the unit of momentum, you can see here we already derived the unit of momentum without knowing, or without we derived it easily without having to memorize it or ask what is the unit of momentum. So you don't have to memorize anything here. Just you go back to the equation here. If you see momentum P equals m times v, so the mass is measured in kilogram while the velocity is measured in meter per second. So all you need to do is multiply the meter per second and the kilogram, because they are multiplied here, so the units will be multiplied. So you will obtain the unit of the momentum to be kilogram meter per second. Very simple. You don't have to memorize anything, and you do the same thing for any other problem in physics. Always be guided by the governing equation. It will guide you to the unit. Okay, now this is actually the SI unit of momentum. You might find different units, for instance kilogram, for instance kilometer per hour instead of meter per second, or you could say, for instance gram meter per second or centimeter per second, and so on. But this is the SI unit, and I would encourage you always to work with SI units if you are allowed to, or if the question doesn't restrict you, because they are more convenient. Okay, let's take another example. Here, example 2, we have a diagram here. We have two cars, the red car and the blue car. They both have the same masses, 1000 kilogram, same speeds, 25 meter per second, and they have different velocities. The red car is moving toward the east, so its velocity is positive 25 meter per second, while the blue car is moving toward the west with a velocity of minus 25 meter per second. Now, why we say minus? Because I assume that the positive direction is in this direction, okay, toward the east. So if my convention is this direction, if I choose this direction to be the positive, okay, that means any direction in the opposite will be negative. So that means here this one is moving in the opposite direction, but the blue car is moving in the negative direction. Okay, okay, let's try to solve this problem. Before you see the answer again, please always try to solve the problem yourself, then we'll compare with the answer. The question asks here for the momentum of each car, and the part B asks if they are the same or different. Okay, so again we follow the same strategy. We draw the diagram, and then we extract the givens. I didn't extract the givens here because it's already shown in the previous example, just to keep the slide not filled. So here the equation of the momentum, or the governing equation, we have mass times velocity. We calculate that for the red car. The mass is 1000 kilogram, the velocity is plus 25 meter per second. We multiply those numbers and we multiply the units. We will obtain 2.5 times 10 to the power 4 kilogram meter per second. This is the momentum of the red car. Okay, it's plus, or I could say to the east. I should write the word here, east, or toward the east, or write it plus here. So sorry for forgetting that. For the blue car, the same thing. We follow the same strategy. We multiply the mass times the velocity, and we will obtain minus 2.5 times 10 to the power 4 kilogram meter per second. You can see here, this answer is positive, but this answer is negative. That means the momentum of the red car is positive, or in the positive direction, but the momentum of the blue car is negative, or in the negative direction toward the east. Sorry, the west. Okay. Let me clear this again. Now, to answer the question, or to see or to compare if we already answered the two questions, the first question we already answered. We calculated both momentums for each car, and if they are different or not, you can see here, you can tell from the answers that they are not the same, they are different, although they have the same magnitude or the same values, but they have different directions. So they have, both cars have different momentums in terms of direction, okay, despite the fact they have the same value. Okay, now based on this conclusion, I would like you to answer this question here. Is momentum a scalar or vector quantity? Just to remind you what we mean by scalar or vector quantity, usually a scalar quantity is a quantity that you can describe it using only its value or its magnitude. For example, if someone asks you what's the time now, you would say it's 4 o'clock or it's 9 o'clock. So you don't have to say any direction, and the information is just complete. So we call those kind of physical quantities, we call them scalar quantities. For instance, also if you're talking about the mass here, the mass of the red car is 1000 kilogram. I didn't say north, south, east, west. I don't care, because the mass can be described without any direction. So the mass is a scalar quantity. But here, for instance, the velocity is not a scalar quantity. It needs to be specified in terms of direction and magnitude. For example, if someone tells you that a car is moving at 25 meters per second, you would feel that the information is not complete. So you would ask, uh, in what direction is the car coming from Amman or going toward Amman? So you need to specify the direction in order to understand the information. So we say that the velocity is a vector quantity. It is described by specifying its value and direction. Okay, so for instance here the speed represents the value or the magnitude of the velocity without the direction. Okay, so we can say here the direction and the speed gives me the velocity. Now based on this definition of a scalar quantity and vector quantity, just tell me whether the momentum is a scalar or vector quantity. Okay, let's take another example here. I'm trying to give you different examples because in every example we discuss a new idea. Pointer, highlighter, it is not here. Okay. Okay. Example 3. Calculate the momentum of a 148 gram baseball falling at a constant velocity of 35 meters per second. We have here this baseball that is falling down at a velocity of 35 meters per second, and it has a mass of 148 gram. Okay, so we want to calculate its momentum. Again, here you can see that the mass is given in grams, so it's not SI unit here. What I need is to convert it or convert the velocity to be consistent with the mass. So here, for instance, I would choose to convert the mass into kilogram because it's SI unit, instead of converting the velocity from meter per second into kilometer per hour, for instance. So it's easier for me to work with SI units. They are more convenient. So please here, whenever you have any problem to solve in physics, before you start doing the calculations, try to read the question and obtain the givens and try to see if their units are consistent. You have to work with one system of units, either SI unit or any other system. But I would encourage you to use SI units always if you have the option to. So here the mass, if we convert it into kilogram, it will be 0.148 kilogram. Just divide by 1000 because we know that 1 kilogram equals 1000 gram. So if we divide by 1000, we will obtain this number. and the velocity is already given in meter per second, so it's SI unit. All we do now is just write down the governing equation of the momentum and substitute the numbers here and multiply them, and we will obtain 5.2 kilogram meter per second, which is the momentum of this ball. Now I have written here the word downward to specify the direction. If I didn't write the word downward, I should have written minus sign here. Okay, so the minus sign specifies the direction of the velocity, or here the direction of the momentum. Okay, let's take another example here. Okay, the sprinter here in this picture is running at a velocity of 40 km per hour with a momentum of 722 kilogram meter per second. Find his mass. Okay, so there is a man here on the move. He is running, so he has a momentum. He's moving at this velocity, and the momentum is already given, but I need to calculate his mass. The difference in this example here you can see is that I am not asked to calculate the momentum, but to find one of the other variables to find the mass here. Okay, again I would encourage you to try to solve it and then compare with the answer. Okay, let's start by the units. The velocity here is given in kilometer per hour, but the momentum is given in kilogram meter per second, so the units are not consistent. I need to convert this one or convert this one. Since this one is given in SI units, let's leave it there and convert this one. Okay, so the velocity needs to be converted into meter per second. Since we know that 1 kilogram is equivalent to 1000, 1 kilometer is equivalent to 1000 meter, and the hour is equivalent to 60 minutes, and each minute is equivalent to 60 seconds. So that means I will multiply by this factor, multiply the 40 by this factor, and then the result, or the value that I will obtain, will be given in meter per second. Okay, so the velocity is 11.11 meter per second, and since the momentum is already given in kilogram meter per second, all I need to do is to write down the governing equation and just substitute the values. But here, since I'm asked to calculate the mass, not the momentum, so I can do some mathematical manipulation, very simple manipulation, to to write the equation in terms of finding m. Okay, so here if I divide both sides with v, here I will have p over v, but here I will have only m, just like here for instance. So m equals p over v. Always whenever you're dealing with those mathematical manipulations, those simple ones, just try to have the quantity that you are required to calculate, have it on one side and everything else on the other side. Okay, now this is one way. If you don't like this way, you can use this triangle. Okay, so here p equals m times v. If you want v, you say v equals p over m, or divided by m. If you want m, you can say m equals p divided by v. Okay, so this here sign represents in the division, while this one represents the multiplication. Okay, so now we have an equation to find the mass. It's p over v. So we have the value for the momentum, we divide it by the value for the velocity, and we will obtain the mass. And for the unit of the mass, also again I can derive it without having to memorize it, since the unit here is kilogram meter per second, and the unit for the velocity is meter per second. So meter per second and meter per second will cancel each other out, and you will be left with kilogram, which is the unit of the mass. Okay, so here we can see that the new idea in this example is that I have to convert the units, and the other idea also is that I may be asked to find some other variable than the main one. Okay, some of the independent variables here, for instance. sometimes in the SAT exams, you might face or encounter similar questions. So you need to be able to use the equation itself, which describes the relationship between those three variables. Here, for instance, they are written. So this equation describes the relationship between the three variables. So you can calculate any one of them if the other two are given. Okay, you just need to be good in math. Okay. Now, in order to help you understand the concept really well and digest it, I have tried to change the question or the example 4 to add some modifications to it. Here, for instance, I have written this question: what will be the momentum of the sprinter in example 4 if the mass is doubled, or if the speed dropped to half its value, or if the mass decreased by a factor of 1/3 and the speed was doubled? Okay, so here what you need to do is to pause for a while also and try to solve, and then after that compare with the answer. Okay, so we will start first by getting the information from the example 4. We have the mass 65 kilogram and the velocity was 11.11 meter per second and the momentum was 722 kilogram meter per second. So the question says here in part A, what will happen to the momentum, or what will be the new momentum if the mass was doubled? Okay, so what I do here is I write down the governing equation, this one, P equals mv, or m times v, and any variable that is changed, I just replace it with the new value. For instance, here in part A, it says that the mass was doubled, so I will replace this m with 2m and continue. So let's see how we can do that. Okay, part A. This is the governing equation. It says that the mass was doubled, so I will replace m with 2m and then I continue multiplication. Here, before you substitute the value of m and the value of v in order to calculate the momentum, it's easier for you to deal with the variables or with the symbols first and substitute only at the end. Okay, so here if I bring 2 outside and I multiply m times v and put them inside brackets, okay, this will give me mv, which is the same as this one. So I will replace it with p. Okay, that means p will equal 2p. The new p equals the equals twice the original p. Okay, so here all I do is just replace p with its value from the previous example. It was 722 and I multiply it by 2. The result will be 1444 kilogram meter per second. Okay, the conclusion here is that when I doubled the mass, the momentum was doubled. Okay, you can see here the momentum was doubled. The same thing here for part P. For part B, speed halved. The speed was decreased by a factor of half. So what will be the new momentum? Again, I go to this V and I replace it with half V. Here you can see. So m times half V, I bring half here and I will be left with m times V, which is P. So the result will be half P. If I multiply here, I will obtain 361 kilogram meter per second. If you compare this momentum, the new one, with the original momentum, you can see that it's half the value. So again, I can conclude here that if the velocity was halved, the momentum will be halved. Okay, so here we can see very simple equation or very simple calculations that I think if you master them, you can use them in any problem in physics, and they will make it easier for you to solve if you have SAT exam or any other exam, because usually in the SAT exam they do bring questions in this way, where you don't have sometimes to substitute values, just they want you to tell them what will be the new momentum. Will it be twice or half, or will it how it will change? So for instance, they give you this question without the values. They will tell you if the mass was doubled, what will be the momentum. So you do this here and you will find that the momentum will be doubled. They might tell you, for example, if I increase the mass by a factor of 5, what will be the momentum? Do the same thing, you will see that the momentum will be 5 times the original value, and so on. Okay, now the reason why here, why any change in the mass or any change in the velocity will give you the same change in the momentum. The reason for that is because we have linear equation here. Remember, we said we have linear momentum. What we mean by linear momentum is that it's described using linear equation. And what we mean by linear equation, I don't know if you have learned that in math, but I will show you here. If you have y and x, this is the coordinate system, for instance, and you have this quantity that is changing this way, or this graph representing the change of y as you change x. Let's consider this momentum, for instance, okay? The change of momentum or the slope. Now, when the equation is written in this way, y equals mx plus b, this equation we call it linear equation. Okay, so y is the y-axis, x is the x-axis, while m is the slope of this line, okay, and b is the intersection of this line with the y-axis. If it goes through the origin, that means the intersection is 0, so b will be 0. There will be no b here. Let me delete it, it's easier. And the equation will look like this one. So this is a linear equation. If you compare this equation with the equation of momentum, you will see that they are the same. Okay, let's consider y to be the p and consider x to be v. So m will be the slope of the line. Okay, so if you are, for instance, given a graph in SAT exam where the graph looks like this, let me draw it again. I will waste time for it, but it's okay. I think it's good information for you. So here, if we have this graph where it says momentum is changing with velocity, and that momentum is described using this figure or this graph. So all you do is to calculate the slope of this graph, okay, and the slope will be the mass of the momentum. If, for instance, the question asks you to find the mass, it will be there will be here, for example, values for the velocities and values for the momentum, and you will be required to find the mass. Okay, so the mass, if you compare with this equation here, for instance, I can write P equals M times V. Just compare them and find the slope, and you can see that the slope is P equal P divided by M by V. So that's the slope here divided by V. Okay, and I think I hope it was simple and easy to understand. Erase those because they will show in the next slide. Okay, let's go to the third part, or the part C. It says that if the mass was decreased by a factor of 1/3 and the speed was increased by a factor of 2, what would be the new momentum? So here I go and I change both variables. The m is changed by 1/3 of its value, and the v is changed by factor of 2, and then I do the same strategy here. I do the same manipulation. I bring the 2 here, multiply it by the third. It will be 2 over third, and m times v, I put it inside the brackets, and since m times v gives me the p, so that means the answer will be 2/3 of the original value of momentum. So if I multiply by the original value, then it will give me 481.33 kilogram meter per second, which is the new momentum. Okay, so here you can see that in order to change the momentum, you can either change the velocity or change the mass or change them both. Okay, so this is again the relationship that describes or the equation that describes the relationship between momentum, mass, and velocity of an object. Okay, remember this is the main equation, and it helps you understand everything about momentum. Okay, now to ensure that you understand the topic really very well, I want you to solve those practice questions 1, 2, and 3. What would be the sprinter's momentum if he was at rest? Number 2, if his momentum dropped to two-thirds of its original value, but the mass did not change, what would be his new velocity? Okay, so I'm asking you here about the velocity, not mass, not momentum. So there is a change in the momentum, and the mass did not change. What would be the new velocity? Question 3, if a light photon is massless, what is its momentum? We all know that light is made of photons, and those photons, they are massless, they don't have masses. So what would be the momentum of a light photon? Think about those questions and ask me if you have any question. Okay, with that, I think we have covered everything we want in this lesson, and I hope it was simple and easy to understand. And just to make sure you really understand it very well, I will try to demonstrate or do a virtual experiment using online tool. uh, we call it FIT simulation. I will show you just in a while. Now to do that simulation, we will try to mimic a one of those examples, for examples, or try to imagine if we change the mass or change the velocity, how the momentum will change and so on, and we will try to do that. Okay, so here let's go and go back again to schedule annotation. Okay, here this is the online simulation tool. I can change the mass, I can change the velocity, and I will read the change in momentum instantaneously. Okay, so let's go to the question. It says that I have a ball of 1 kilogram that is rolling at a speed of 30 centimeter per second, and what is its momentum? So imagine you have a billiard ball that is rolling on the floor at a speed of 30 centimeter per second, and its mass is 1 kilogram. So what do you think would be its momentum? Let's see how we can get it. This is 1 kilogram, and this is the velocity. It's 0.3 meter per second, which is equivalent to 30 centimeter per second, but I have converted it. Okay, so we can see here the momentum is 0.3. So just directly calculated 1 times 0.3 gives you 0.3 kilogram meter per second. This is the momentum of that billiard ball. Okay, so let's run the simulation. You can see here this is the momentum and this is the velocity. You can click here to show you the arrow that represents the momentum or the arrow that represents the velocity. I'll bring it again here. See here, this arrow, the green one, represents the velocity, and its length gives you an idea about the value of the velocity, while its direction tells you in what direction this velocity is. For the blue arrow, it tells you the same information but about momentum. Okay, and here the values are given in absolute values, velocity and the momentum. Now let's do changes. Okay, let's change the velocity or change the mass or change them both and see how that will affect the momentum. Let's go back to the question here. Part A, it says if the mass is doubled. Let's double the mass and see what will happen to the momentum here. Here is the mass, not 1, I want to double it, so I will put it 2. See, the momentum was doubled, directly becomes 0.6, it was 0.3. And you can see here also the arrow that represents the momentum increased in length to give you an idea that the momentum has increased, while the velocity remained the same because I didn't change the velocity. But also, if you can see here, the size of the ball increased because I increased the mass. Okay. Okay, let's go and see the second part. If the speed becomes 2.5 times its original value, In other words, if I increase the speed by a factor of 2.5. So let's go and try to change the speed. But before I do that, I want to bring the mass back to its original value. Okay. Let me bring this back here. Okay. So the now we have brought everything to its original value. The mass is 1 kilogram and the velocity is 0.3 meter per second. So the momentum is 0.3 kilogram meter per second. If I increase the velocity by a factor of 2.5, in other words, I multiply this value by 2.5, which will give me 0.75. You can do that using the calculator or just using pencil and pen and paper. So now if I increase the velocity, you can see the momentum also increased. It becomes 0.75. Okay, if you want to make sure, you just multiply this number by this number. Okay, and you can see also that the green vector or the green arrow increased in length to tell you that the speed increased, but the mass decreased. Sorry, didn't change, because I didn't change the mass here, and the momentum changed. Also, the arrow of the momentum increased. You can see here also the velocity is a little bit faster than before, which gives you an idea about how if you increase the velocity, the ball will move faster. Okay, the third part says if the mass increases 3 times, but its speed drops to 1/3 of its value. So let's bring them back first to their original values, both of them. Those are the original values. Okay. Now it says, for the part C, says the mass increased 3 times, but the speed decreased to 1/3 of its value. So here I changed both variables or both quantities, the velocity and the mass, and I try to determine how that will affect momentum. So let's increase the mass 3 times. Watch out for the ball and see how it will change in size. See, it changed. And the velocity we will decrease it by a factor of 1/3. That means we divide this value by 3, so it will give me 0.1. Okay, so you can see here the velocity dropped, very small. This arrow is very small, while the momentum uh, dropped but not much, or remained the same. Actually, it didn't change here, and I'll tell you why. Let's run it first, and you can see here it's moving very slow because the velocity is very low and its size is very large, but the momentum remained the same. It didn't change. So why is that? Why the momentum didn't change although I changed the velocity and I changed the mass? If you think about it here, we have changed the mass, increased it 3 times, which would increase the momentum, but at the same time we decreased the velocity by 1/3. Okay, so which will decrease the momentum. So any increase in the momentum caused by increasing the mass was cancelled out by the decrease in velocity, because the decrease in velocity will cause the momentum to decrease, while the increase in mass will cause the momentum to increase. So this one will cancel out this one. Okay, that's why the momentum remained the same. So this tells you an idea that you could maintain or keep the momentum constant although you change the velocity and the mass. If you do that in such a way that each effect will cancel out the other effect, you can have momentum that is constant. Again, if you want to explain this, you go back to the equation, the governing equation here. You change the mass, you change the velocity in such a way that they keep P constant. Okay, and I hope everything was clear and easy to understand. And that's everything for today's lesson. Um, before we finish, I want you to read this or think about this question for the next lesson. The next lesson will be about impulse and change in momentum. So try to answer this question and this question so that you will be prepared for the next lesson. What causes an object to change momentum? If you remember the car that was crashed, its momentum changed. So what do you think caused it to change? And also here, if you see, you have two situations where the egg here was broken, but here it didn't break. So try to explain using physics why is that, why this one didn't break and this one uh, was broken. Okay, and that's for next lesson. Now I have a gift for you, which is online game I have designed for today's lesson, and you can play it online from wherever you are. uh, I have some instructions here. Sorry. Okay, so this game, for you it will be fun, but for me also it will help me understand your progress and see if you understood the lesson or not, and if you still need any support. So please play it. So it will send me back the feedback, and which will help me, of course, understand your performance or to assess your understanding. Okay, and you will have fun by playing this game, and you will be there will be also first winner, second, and so on. So I have set a challenge deadline. The deadline for the challenge is May 9 on Sunday at 3:30 afternoon. Okay, so you have to finish it or to play it before this deadline. Okay, so you will need a phone or PC or tablet or anything with internet connection, and you will need paper and pen. Okay, and then you will go to you will need paper and pen because some questions will require you to do some calculations quickly. Then you will go to this link, and after you open the link you will see this screen, and it will ask you to enter your username. So put your name as username and start playing, and watch out for the time. Different questions have different time limits. Questions that are simple, they have less time, for instance 30 seconds or 1 minute at the most. And questions that need calculations, you might have 1 minute, 1 minute and a half, or 2 minutes, and so on. And at the end, you will see your position, you will see your performance, if you obtain the first rank or the second rank, and so on. And you can send me feedback also. At the end of the game, you will see a small survey, 3 or 2 questions where you can give your feedback about the game or about the lesson. And thank you very much, and I hope you have learned something from this video. Wish you the best, and Eid Mubarak. Salam.